In this lesson, we'll review a few of the basics from trigonometry. We're going to focus mostly on sine of theta and cosine of theta, where theta represents some angle. To help us do this, I've included a graph of the unit circle centered at the origin. The origin 0, 0, and the radius is 1. This is given by the equation x squared plus y squared is equal to 1. We can use this unit circle to start talking about angles. So if we start here on the positive x-axis, we can say that this is 0 degrees. And if we rotate up to here, we've gone 90 degrees. If we rotate again down to here, that is to 180 degrees. If we rotate from here to here, we'll say that's at 270 degrees. And if we go from here to here, then we've gone 360 degrees. So if we start here and don't rotate at all, this location is the same thing as saying you rotated 360 degrees. Because this circle has a radius of 1, the circumference, the distance around the circle, is 2 pi, and that comes from the formula the circumference is equal to 2 pi r. This will allow us to come up with a different angle measurement called radians. So if we start here and we don't rotate, we can say that that is 0 radians. But if you do a full rotation, you've gone 2 pi, so we could say as a measurement, that's also 2 pi radians. So here these are radians versus these, which are degrees. So 0 degrees and 0 radians is the same thing, but 360 degrees and 2 pi radians is the same thing as well. 360 is the distance around once, and then 2 pi is that angle measurement too. Well, if you do a half rotation, what is that in terms of not degrees but radians? Well, it'll be half of 2 pi, which is pi. So 180 degrees and pi radians are at the same location. If you take half of that, that'll be pi over 2. So this is also pi over 2 radians. And here, this is 3 pi over 2 radians. So we can use either degrees or radians when it comes to measuring an angle. Going 90 degrees is the same thing as pi over 2 radians. Going 180 degrees is the same thing as going pi radians. Going 270 degrees is the same thing as 3 pi over 2 radians. And then doing a full rotation of 360 degrees, well, that's the same thing as 2 pi radians. Okay, now how does all of this relate to sine and cosine? The idea for these functions is you plug in an angle and it gives you a number back. Here is how they are defined. What you can do is you can create an angle theta like this, which I'll draw with the positive x-axis and then by another ray coming out this way. So here we have an angle, and I'll call that angle theta. And what happens is it hits the circle, and that point has an x-coordinate and a y-coordinate. So here's an angle that meets the circle, and you get a number for the x value and a number for the y value. What's the x value and what's the y value? Well, that's exactly what we call sine and cosine. In fact, the y value is what we call sine, and the x value is what we call cosine. And so that's the definition of these two things. You draw an angle, it meets the circle, you get an x and a y value, and we call those either sine or cosine of theta. All right, so quick review time. Here's an identity that you've probably seen when taking trigonometry, and that is sine squared of theta plus cosine squared of theta is equal to what? It's always equal to 1. Why is this true? Where does this come from? Well, the circle is x squared plus y squared is equal to 1. That gives us this equation. And sine and cosine are what we call x and y. If you take this equation, so we take the equation which is x squared plus y squared is equal to 1, and you simply plug in cosine for x and sine for y, you would get this. Okay, so that's cosine of theta squared plus sine of theta squared is 1. So the notation we use when squaring sine and cosine is to put the squared here. So let's call this cosine squared theta and sine squared theta. And it doesn't matter if you write the sine or cosine first, but it does take us back to this very important identity. So that's actually where this thing comes from. It comes from the definition of sine and cosine in a unit circle. Now that we have a definition for sine and cosine, let's go over evaluating these functions at a few angles. So I'll put down, sine of theta and cosine of theta, and I'll make a little table here, and I'll choose a few angles that we'll put into these two functions. And I'll use 0 radians, pi over 2 radians, and then pi radians. Can we figure out what sine and cosine are equal to at these measurements, these radian measurements? Let's start with 0. 0 radians is right here. So if you don't rotate at all, we're at this spot on the unit circle. And that point is 1 for x and 0 for y. It's a unit circle, the radius is 1, so the x value is 1 and the y value is 0. So what's sine of 0 and cosine of 0? Well, sine is the y value, so this is 0, and cosine is the x value, which is 1. So this is the same thing as saying, what's sine of 0 radians? Well, it's 0. What's cosine of 0 radians? Is 1. For pi over 2, okay, so let's say 90-degree rotation, and that'll give us this spot here. And let's see, the x value is now 0 and the y value is 1. Okay, so that tells me, well, if I want to know cosine of pi over 2, that's the x value, and so that is 0. And what is sine of pi over 2? It's the y value, which is 1. That is, sine of pi over 2 is 1, and cosine of pi over 2 is 0. And I had one more. Here is pi radians, a 180-degree rotation. What point is this? It's -1 for x and 0 for y. Said another way, sine of pi is 0. That's the y value. What is cosine of pi? It's the x value, which is -1. That is, sine of pi is 0, and cosine of pi is -1. So determining sine and cosine at any 90-degree rotation, it turns out to be pretty simple, but there are 3 other very important angles that you should be familiar with. And those angles are as follows: 30 degrees, 45 degrees, and 60 degrees. I'd like to make a chart with sine and cosine for those 3 angle measurements, but I'll list them in terms of radians, so I'll put that down here. That is, what is sine of theta and cosine of theta if we're looking at the angles of 30 degrees, which is pi over 6, 45 degrees, which is pi over 4, and 60 degrees, which is pi over 3. So that's 30, 45, and 60 degrees. These are not so easy to compute. I'm just going to list out their values. Sine of pi over 6 at 30 degrees is 1/2, or 0.5. At pi over 4, it is root 2 over 2. And at pi over 3, it is root 3 over 2. What are the corresponding values for cosine? They are the reverse of these numbers. So it starts at root 3 over 2. It goes to root 2 over 2, so sine and cosine are the same there. And then at pi over 3, it's equal to 1/2. These angles will show up a lot when we're solving trig equations, so they're very good to know. These ones are easy to compute, but really for these, we just have to remember them. Let's try applying them in a couple of examples. In example 1, I want to evaluate the trig functions sine and cosine at the angles, the radian measurements of 5 pi over 4, 5 pi over 6, and -pi over 3. Let's start with this one here. What is sine of 5 pi over 4? Now this pi over 4 makes me think of on the previous slide, the angle pi over 4, which is right here. That is a 45-degree angle. That's pi over 4. The first thing to think about is, well, where is 5 pi over 4? Radians is nice because you can actually count by pi over 4s to find where this is. So here's 0. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and then finally here, 5 pi over 4. So this is the location of 5 pi over 4. So here we go. I now know where 5 pi over 4 is located. Now the next piece of this is, well, all right, what's sine of pi over 4? That is something we know from the previous slide, and the answer is root 2 over 2. So we have to know this piece of information. It turns out that this sine of 5 pi over 4 is either equal to this number or it is the negative of this number. It's one of those two options. And how do we determine which one it is? Sine of pi over 4 is the y value at this spot, which is a positive root 2 over 2. The y value of this spot has got to be negative. And therefore, the answer to this part is this is equal to negative root 2 over 2. A quick trick here, if you're looking for 5 pi over 4, if you can remember the location of pi, and you want to get to 5 pi over 4, you can think of pi as the same thing as 4 pi over 4, because now you can simply add one more pi over 4 to go from 4 to 5. So it's a way that can help you get to the location that you're looking for just a little bit faster. Let's try using that idea here in what is cosine of 5 pi over 6? Looking at this, I mean, the first thing I'm thinking of is pi over 6. Where is that? I know that's a 30-degree angle, so that's right here. Now, the next question is, well, where's 5 pi over 6? Which quadrant is that in? The first, second, third, or fourth? Well, you could count pi over 6, but actually, I know where pi is, and pi is the same thing as 6 pi over 6. So here to get to 5, you're going to go backwards by pi over 6. So here is the location of 5 pi over 6. Essentially, I thought of pi as 6 pi over 6 and went backwards 1 pi over 6. So from here, all right, I know what cosine of pi over 6 is. I know that it is equal to root 3 over 2. So this thing is either equal to this or it is the negative of it. All right, well, cosine is the x value at this point, which is root 3 over 2. And here, the x value has to be negative because we're to the left of 0. So this means this is negative root 3 over 2. So that just came from the fact that an x value here is positive and its corresponding x value over here is negative. So I take the negative of this. Last one here. What is sine of pi over 3? Negative pi over 3. And it's making me think pi over 3, which is here. That's a 60-degree angle, pi over 3. Where is negative pi over 3? We didn't talk about this in the previous slide, but if this is 0 radians and you rotate in the opposite direction, those are negative angle measurements. So if this is going up to positive pi over 3, we'll take this as going down backwards to negative pi over 3. So it's here. Okay, so here we go. I thought of pi over 3, and I used that to help me figure out where negative pi over 3 is equal to. I'm now going to think about, well, what is sine of pi over 3? And that's equal to root 3 over 2. So again, we have the situation of, all right, sine of negative pi over 3 is either equal to this or it is the negative of this. The y value here is positive. Sine is the y value down here, which is negative. Therefore, this is the negative of this as well. These all turned out to be the negative of the other value. So maybe just one more where that doesn't happen. What is cosine of negative pi over 3? Again, my thought process is find pi over 3. Think of that first. Use that to find negative pi over 3. Okay, we did that. Do we know what cosine of the pi over 3 angle is? And the answer is, yeah, it's a half. Okay. What is cosine of negative pi over 3? It's either the positive or negative of this value. Cosine is the x value. These have the same x value, and they're both, in this case, positive. So cosine of negative pi over 3 is equal to positive 1/2. Last thing to review is, what do the graphs of these functions look like? And I'll focus on sine. How can you actually go from taking the definition of sine on a unit circle and graphing it in the x, y plane? How do you do that? And the idea is pretty simple. You can go to your unit circle and say, well, this is 0 degrees or 0 radians. And here, this is the point that corresponds to it, which is the x value is 1 and the y value is 0. Since we're talking about sine, we care about the y value. Down here, instead of thinking about rotating this way for your angle, we'll list the angles out on the axis here. So where is 0 radians? Here. What's the corresponding y value for sine? It's also 0. So we plot the point 0, 0. I think the next obvious place to go is here, to pi over 2 radians. And this corresponds to the point, okay, that is 0 for x, but 1 for y. And 1, that's the value of sine. Here I'll mark pi over 2 on this axis. The corresponding value of sine is 1, which I'll put up here. If we rotate down to pi radians, which is here, this point has an x value of -1 and a y value of 0. And 0 is the sine portion of it. So at pi radians, we actually get 0 back for sine. If we continue to here, this is 3 pi over 2. That's the point 0, -1. And here, -1 is sine. So at 3 pi over 2, which is here, we'll plot -1. If you do a full rotation, 0 is the same location as 2 pi radians, and we have the same value for sine, which is 0. If you connect this with a smooth curve, you get something that looks like this. You need more points to get a more accurate graph, but here's one period of sine, and it comes from thinking about, at given angles, what is the corresponding y value? And then you plot those y values. What happens if you go backwards? The equation will look like this. This should be copied and pasted forever in both directions. But the reason is, if you go backwards to negative pi over 2, which is here, the value of sine is -1. If you go backwards to negative pi, so I'll plot that here, this is negative pi, what is the corresponding value for sine? Also 0. If you go backwards to -3 pi over 2, which is here, we have that sine is equal to +1. And then lastly, if you do a full rotation backwards to -2 pi, which is here, we get that the corresponding value for sine is 0. And if you connect these with a smooth curve, you get a graph that looks like this. Again, you do need more points to get the accurate picture, but just using the ones that occur at 0, pi over 2, pi, and 3 pi over 2 will give you a good idea of what the graph looks like. I encourage you to try this for also cosine. You get a similar type of graph, but it is shifted just a little bit to the right. So that's everything I wanted to review first from trigonometry, but there'll be a few more things that we'll cover in the coming lessons.